Hi and welcome to Quick Add Math on Quadratic Equations in Simultaneous Equations. The first prerequisite is that you should already have a good understanding of what is covered in Quick Math about simultaneous equations. The second prerequisite is to be able to apply the factorization method to a quadratic equation. The third prerequisite is to be able to apply completing the square method to a quadratic equation. The fourth and final prerequisite for this segment is to be able to apply the quadratic formula method to get to a solution for any quadratic equation. Equipped with the four prerequisites, we can now move on proper to simultaneous equation involving one linear and one non-linear equations. As an example, solve the simultaneous equation y equals 3x and y equals 2x squared minus 5. Given that y is equal 3x and 2x squared minus 5, it is obvious that 2x squared minus 5 is also 3x. By rearranging the equation such that the quadratic equation is on the left-hand side and the right being equated to 0, we could then factorize the quadratic equation and solve for x. Knowing x, we could put the x value into one of the equations, for example in this case y equals 3x, and solve for y. In the first instance, this will be 7.5, and when x is equals to -1, y will be -3. The solution required is therefore the coordinates 2.5, 7.5, and the coordinates -1, -3. Now it's your turn to attend to tutorial question 1. Solve the simultaneous equation 3y equals 4x minus 5 and x squared plus 3xy being equal to 10. Given that 3y is equals to 4x minus 5, we could make the 3y portion of the second equation to being replaced with 4x minus 5 as shown. Then expand on the quadratic equation, factorize to identify the required x values. We will then reinsert each of the x values into the 3y equals 4x plus 5 equation to solve for y. You could also verify for correctness by inserting the identified values of -1, -3, and 2 and 1 by substituting this to the other equation where the equation must continue to remain valid. Let's get on to tutorial question 2, which is to solve the simultaneous equation xy equals 12 and the product of x1 and y plus 2 being equal 15. Given that xy is equal to 12, it means y is equal to 12 over x. By replacing the y with 12 over x in the second equation, we could then expand on its left-hand side and work towards factorizing it to identify the values of x, which should be -1.5 and 4. Then solve for y with the substitution of the x values in any one of the two above equations. Also, to verify for correctness, you could check these values by substituting them into the other equation and seeing that this equation must continue to remain valid. Tutorial question 3 is where one can apply simultaneous equation given some sets of parameters. In this question, the sum of the areas of two square objects are stated as being 818 cm square, and the sum of both parameters is 160 cm. What are the dimensions of each of the two stated squares? Unlike tutorial question 1 and 2, where the simultaneous equations are given, in this case, you would start by formulating the simultaneous equations. From the sum of areas, and with each square having the side length of x and y, it would be obvious that the sum of x squared and y squared must equal to 818. As for its parameter, 4x plus 4y in turn must equal 160. This sets the first two simultaneous equations. From the second equation, we can decipher that y equals 40 minus x. We can then take the next step of substituting 40 minus x into the y portion of the second equation, then expand on the quadratic equation, factorize it to solve for x. We shall then continue to solve for y to get to the final required dimension of each square being 17 cm and 23 cm in length. Tutorial question 4. Find the midpoint and the length of the 2 points of intersect from the lines of 2x plus 5y equals 1 and x squared plus 5xy minus 4y squared plus 10 equal 0. From the first equation of 2x plus 5y equals 1, we can decipher that x is the product of half and 1 minus 5y. By substituting this to the x portion of the second equation, we now have a quadratic equation in terms of y. Next, we can expand and solve for y and move on to insert the y values into the first equation to solve for x. With this, we should get at the 2 points of intersect being 3 minus 1 and minus 2, 1. It doesn't stop here, as the requirement is to identify the midpoint, and this would be the average of the 2x values and the y values. Secondly, we are tasked to identify the length of the 2 points, which is the Pythagoras of its x distance and y distance, which should come to this being a square root of 29 or 5.39 correct to 2 decimal points. That's the gist of simultaneous equations involving quadratic equations. If you found this beneficial, do look out for our other tutorials.